So I've taught you all these wonderful ways of factoring, but the hardest part can be deciding, what is the one that you're supposed to be using for your certain polynomial that you're trying to factor. So I've created this flowchart for you. Unfortunately, the way my screen recorder is, I can't show you the whole thing at once, so I'll kind of just jump from section to section. But this is your thought process for when you're trying to factor a polynomial. So the first thing, and I've been saying this over and over again, is that you should always look for a GCF. Always, always, always. Always the first thing. Remember that it can be a number, it could be a variable, or a combination of both a number and a variable. And if that leading term is negative, we do want to factor out the negative. If the leading term is positive, we don't want to factor out a negative at all. So only if that leading term is negative, we're going to factor it out. And then three things can happen. We can have a binomial, we can have a trinomial, or we could have four terms. So we are going to start with our binomial section. And the only thing that can happen with a binomial, once again, after possibly factoring out a GCF, is this difference of two squares. So that's that special pattern when we have a squared minus b squared. That's a perfect square, that's a perfect square, minus in the middle. It factors into a plus b and a minus b. Once again, it does not matter which comes first. If you put the minus, then the plus, it's really the same thing. So for our examples, x squared minus 64, x squared is a perfect square, 64 is a perfect square. There's a minus in the middle. There was no GCF. I did notice that, forgot to say it. No GCF, so difference of two squares. So this one's going to be x plus 8 and x minus 8. For our next one, there is a GCF. Number-wise, a 2 goes into both of them, and an n also goes in. And so pulling out that 2n, that will leave me with 9m squared minus n squared. So my binomial now, I have a perfect square with a minus in the middle. So my binomial is going to be 3m plus n times 3m minus n, and then don't forget that 2n out front. Okay, let's move on to that middle section, which is trinomials. Okay, so trinomials, we had two different scenarios. We had the nice one where there was no coefficient out front. That was the super fast one. And then we had that other type where there was a coefficient out front, and that was a more annoying, had to split up the middle term one. So let's start with the no coefficient. This is the one where we want to find factors of c that add to b. And once you find those numbers, you just throw them in parentheses and you're done. So for our example down here, no GCF, we want to find factors of negative 42 that add to negative 1. So those two numbers would be negative 7 and 6, which means my answer is just going to be x minus 7 times x plus 6. And we're done. For the next one, there is a coefficient out front, but that's because we need to make sure there's no GCF, and there is here. So we are pulling out a 2. We are left with w squared plus 10w plus 25. We need two numbers that multiply to 25 and add to 10, which would be 5 and 5. So it's going to be 2 times w plus 5 times w plus 5. That one actually happened to be a perfect square trinomial also, so we could also write that as 2 times w plus 5 squared. Okay, our other side here, we have a coefficient. So we are going to be using our factors of AC that add to B. Then you have to split up that middle term, and then you have to factor by grouping. So here, there is a GCF, so let's pull that out first. So we have 3 times 10x squared minus 9x plus 2. And now a times c is 20. So we want factors of 20 that add to negative 9. That would be negative 4 and negative 5. So this is where I'm going to ignore the 3 for now, and I'm just going to work on my trinomial and then make sure I throw my GCF back on when we're done. So we have 10x squared minus 4x minus 5x plus 2. Remember, it does not matter what order you put those two middle terms in, it will work either way. We can factor out from the first two terms a 2x, which leaves me with 5x minus 2. Over here, that must also be 5x minus 2. And to make that work, that must be a negative 1. So my parenthesis that repeats is 5x minus 2. The stuff I pulled out is 2x minus 1. And then don't forget that 3 we pulled out originally. Okay, I do have that spirally section going off to the side over there, which is our what happens when we have that large AC. And that's when you would probably check to see, is this a perfect square trinomial? Okay, and that's when the first part's that perfect square, that second part's, the last one's a perfect square, and then really you have to see if it's really 2 times the first thing times the second thing. So I'm looking at this example. There is no GCF, nothing goes in 36, 60, and 25 besides 1. And then I'm sitting there going, oh my goodness, I need to multiply 36 times 25, whatever that is, find factors of that, then add to negative 60. I'm like, hold up, there has to be a better way on this one. So I look to see, is this a perfect square trinomial? So 36x squared is a perfect square. 25 is a perfect square. We're looking good so far. So I'm going to take the square root of each of those pieces. So this would be 6x. This would be 5. And then we have to check to see, is that middle term really 2 times the first part, which is 6x, times 5, which is that last part. And 2 times 5 is 10. 10 times 6x is 60x. So this is a perfect square trinomial. So inside my parentheses, I put my 6x and my 5. I know it's going to be squared. Remember that middle sign comes from the sign of that middle term because this is negative, this is negative. Okay, and our last section of our flowchart is for 4 terms, and that's when we factor by grouping. Remember, sometimes you might need to change the order to make it work. I think it should work in the order I have. It's good to note there is no GCF here, so we're going to just jump right into factoring by grouping. So I can pull out from the first 2 terms an a squared, which leaves me with 2a minus b. This must also be 2a minus b, and that should be a plus 5. So the one thing that repeated was 2a minus b, and the things I pulled out was a squared plus 5. And there's my answer. Okay, one last thing I want to talk about that is not on your flowchart. Okay, if you printed out the flowchart, just turn it over right on the back, okay, is factoring completely. Sometimes you're going to do these steps, but then what you're left with can still be factored. So you always want to make sure that any polynomial you get as a factor is no longer factorable before you call it quits. So in my first one, I have x to the 4th minus 1. This is a perfect square. This is a perfect square. So my binomial is a difference of 2 squares. So this is going to be x squared plus 1 and x squared minus 1. Okay, this has a binomial with a plus in the middle, nothing else you can do there. But my second factor, I still have a perfect square, and a minus in the middle. So my second factor can be factored even more. So I have x squared plus 1 still, and then it's going to be x plus 1 times x minus 1. And now it is fully factored. For 12x to the 4th minus 3x squared minus 54, I'm thinking maybe I was supposed to put an X on this. Let's see. We have 3x. Oh, no, it wasn't. Okay, sorry. I was trying to think where this one was going. Okay, this is, I'll put that back. Pen. Okay, so this here has a GCF of 3, so we're going to pull out the 3. So that's going to leave us with 4x to the 4th minus x squared minus, that goes into there once, minus 18. And then we want to find, I guess we're doing 18 times 4. I don't like this question. I don't know why I gave it to you. So 18 times 4 is 72. Okay, so we want to find factors of negative 72 that add to negative 1. Oh, this is bad. Okay, so it's negative 9 and 8. And then we need to split it up because this was one with a coefficient, so it's going to be 4x to the 4th. I know we only did this with x squareds, but it's going to work. So 4x to the 4th minus 9x squared plus 8x squared minus 18. From my first two terms, I can pull out an x squared. So that would be 4x minus 9. Over here for my second part, I'm going to have 4x minus 9, and then this will be a plus 2. Oh, sorry, 4x squared minus 9. There we go, 4x squared minus 9. And then we'll have 4x squared minus 9. We have x squared plus 2. And then we bring down our 3. But now this can still be factored because it's a perfect square, a minus in the middle. So 3, this would be 2x plus 3, 2x minus 3, and x squared plus 2. And then that is fully factored.